Next problem. If P and Q are the length of perpendiculars from the origin to the lines x cos theta minus y sin theta equal to k cos theta to theta and x secant theta plus y cosecant theta equal to k respectively, prove that p square plus 4q square equal to k square. So given lines are x cos theta minus y sin theta equal to k cos 2 theta. Write it in the standard form. It is x term, y term, then constant term. So x cos theta minus y sin theta minus k cos 2 theta equal to 0. That is equation number 1. Next line, x secant theta plus y cosecant theta equal to k. That is x secant theta plus y cosecant theta minus k equal to 0. That is equation number 2. We know that the length of perpendiculars from the origin to the line ax plus by plus c is mod c by root of a square plus b square. That is the formula. So we are going to find the length of the perpendicular from the origin to the first line using this formula. So a is equal to cos theta, b is equal to minus sin theta, c is equal to minus k cos 2 theta. So length of the perpendicular from the origin to 1 is mod minus k cos 2 theta by root of cos square plus sin square. So you will get k cos 2 theta. It is equation number 3. But they have given the length of the perpendicular from the origin to the first line is p, small p. So equating 3 and small p, so you will get small p is equal to k cos 2 theta. That is equation number 4. Next we are going to find the length of the perpendicular from the origin to the equation 2. So here a is equal to secant theta, b is equal to cosecant theta and c is equal to minus k. So the length of the perpendicular from the origin to 2 is modulus minus k by root of secant square plus cosecant square theta, which is equal to k by secant square plus cosecant square theta. Formula is secant square into cosecant square. So root of secant square into cosecant square. So square and square root get cancelled. So you will get k by secant theta and cosecant theta. We know secant theta is equal to 1 by cos theta, right? So similarly, cosecant theta is equal to 1 by sin theta. So 1 by secant theta is the reciprocal of 1 by cos theta, that is cos theta. Similarly, reciprocal of 1 by sin theta is sin theta. Cosecant theta is equal to 1 by sin theta. So 1 by cosecant theta is equal to reciprocal of 1 by sin theta, that is sin theta. So k into cos theta into sin theta. So multiplying by 2 and divided by 2. So you will get k into 2 sin theta cos theta by 2. We know 2 sin theta cos theta is equal to sin 2 theta. We are using that trigonometric formula. So you will get k by 2 sin 2 theta. That is the equation number 5. So but the length of the perpendicular from origin to the second line is q, that is given. So equating 5 and q. So q is equal to k by 2 sin 2 theta. Now we need to find 5 square plus 4 into 6 square, right? Equation, right? So p square plus 4q square is equal to k square cos square 2 theta plus 4 into k square by k by 2 whole square sin square 2 theta. So k square cos square 2 theta plus 4 squaring k square by 2 square 4 into sin square theta. So 4 and 4 get cancelled. K square is common, take it outside. K square into cos square 2 theta plus sin square 2 theta. So cos square plus sin square always 1. So you will get k square. Next problem. The perpendicular from the origin to the line y is equal to mx plus c meets it at the point minus 1 comma 2. So perpendicular from the origin to the line, right, y is equal to mx plus c meets the line at the point minus 1 comma 2. That is point of intersection of the perpendicular from the origin to the line y is equal to mx plus c and the line y is equal to mx plus c is minus 1 comma 2. That is given, right? Find the value of m and c. So the line given line is y is equal to mx plus c. So write it in the standard form, mx minus y plus c equal to 0. That is equation number 1. We know the Perpendicular line passes through x1, y1 to the line ax plus by plus c equal to 0 is bx minus ay, which is equal to bx1 minus ay1. Here a is equal to m, b is equal to minus 1, x1, y1 equal to 0, 0. So the equation of the perpendicular line from origin 0, 0 to 1 is minus 1 into x minus m into y, which is equal to minus 1 into 0 minus m into 0. So you will get x plus m equal to 0. That is equation number 2. So the point, given point minus 1 comma 2 is the point of intersection of 1 and 2, correct? That is what they have given, right? So the perpendicular from the origin to the line 2 meets 1 at the point minus 1 comma 2. So minus 1 comma 2 lies on both 1 and 2. Substituting x is equal to minus 1 and y is equal to 2 on both the lines 1 and 2. So substituting in first equation, you will get m into minus 1 minus 2 plus c equal to 0. So minus m plus c equal to minus m plus c minus 2 equal to 0. That is equation number 3. So substituting these values in equation number 2. So minus 1 plus m2 equal to 0. So m is equal to 1 by 2. Put m is equal to 1 by 2 in equation 3. So minus 1 by 2 plus c minus 2 equal to 0. C is equal to 5 by 2. Thanks.